Hi there. In this video we're going to continue looking at solving simultaneous equations, a topic that comes up at GCSE and at A-level, and at A-level it occurs in Core 1 and the other modules as well, but as a subsidiary topic, and it also appears explicitly in Further Pure Maths 1. And in particular I want to focus on the method of setting out your work that they use in the OCR Further Pure Maths 1 module. Okay, let's look at simultaneous equation. Now, what we're going to do is we're going to refer to each of the equations by the row that they're in. So this is equation in row 1, which I'm going to call row 1, and this is the equation in row 2. Now, let's see how we set out our work. Right, the first thing I want to try and do is eliminate one of the variables. I have two variables. I've got y appearing in both rows, and I've got x appearing in both rows. And I want to try and get the coefficients. I want the coefficients to have the same number in front. Now watch how I set out my work. What I'm going to do is I'm going to eliminate the x variable from both rows. So now watch what I do. I write down to show the reader what it is I'm doing. My new row 1, which I call row dash 1, is equal to 5 lots of the previous row 1, take away 6 lots of the previous row 2. Now let's have a look. 5 lots of 6x is 30, take away 6 lots of 5x, so it's 0x. So I've got rid of the x's. 5 lots of 5y, plus 5y, is 25y. Take away 6 lots of minus 2y. So we've got minus 12y. It's going to be subtracted, so it's equivalent to adding. So it's plus 12y added to 25y gives me plus 37y equals 5 lots of that, so that's 215. Take away 30 gives me 185. So 0x plus 37y equals 185, and my second row hasn't altered. Now, how do we proceed from here? Well, what we're going to do is we're going to find out what what y is, and we do that by modifying row 1. So my new row 1 is going to be the previous row 1 divided by 37. I'm going to get the coefficient of y equal to 1. So 0x divided by 37 is 0x, plus 37y divided by 37 is plus 1y or plus y, and 185 divided by 37 is 5. So 0x plus y equals 5. And again, my row 2 is unaltered. So that's my second step. Now, what I'm going to try and do is eliminate the y's to find out what x is equal to. So watch what I do. My new row 2 equals my previous row 2 added to 2 lots of the previous row 1. So let's have a look. Row 2 is 5x added to 2 lots of the x's in row 1. 2 lots of 0 is 0, so it's going to be 5x. It's unchanged. Minus 2y added to 2 lots of y, that's the coefficient of y in row 1, gives me 0y. Now let's have a look. Row 2 is 5 to the right of the equal sign, added to 2 lots of 5, which is 10, so it's 5 add 10, 15. So let's write that now. So row 1 is unchanged, 0x plus y equals 5, and row 2, my new row 2 is 5x plus 0y equals 15. And then we finish off by making sure that the coefficients of both x and of y are 1. So my first line doesn't have to be changed, my first row doesn't have to be changed. And my new row 2 is the previous row 2 divided by 5. That is x, 5x divided by x, 5x divided by 5 is x, 0y divided by 5 is 0y, 15 divided by 5 is 3. And then if I want to make it even more explicit, I'd write that y equals 5. and x equals 3. Right, now, so there's a unique solution. Now let's have a look at a second case. You write this one down. It's obviously it would help not just if you watched, but at the same time you wrote this. Okay, so we're going to solve this simultaneous equation. So let's use the same method of showing our working. That's row 1, 6x plus 2y equals 10, and row 2 is this. Now, what shall I do? I'm going to try and get rid of the x's. So I'm going to concentrate my attention on row 1. So my new row 1 equals previous row 1, take away 2 lots of row 2. Let's go through this. Let's look at the x's in row 1. I've got 6 x's. Take away 2 lots of x's, 2 lots of 3x, that's the amount of x's in row 2, gives me 0x. What about the y's? 2y, take away 2 lots of y is 0y. And then 10, take away 2 lots of 5 is 0. And so my new row 1 is 0x plus 0y equals 0. Row 2 hasn't changed. Now let's stop there. Have we got a solution? Let's concentrate our attention on this line here. Is there no solution? Is there one solution, or is there an infinite number? Well, there is an infinite number. But they're not unique. We can't just put any number for x and any number for y. So whenever we get 0x plus 0y equals 0, this is what we do. Let's look at row 2. Here's the relationship between x and y. What I'll do is, I'll let y equal some other variable, and then we know that 3x plus y, which I replace with t, equals 5. Now what I do is, I make x the subject. So 3x equals t, take away 5, so x equals t, take away 5 all over 3. So my solution is y equals t and x equals t minus 5 all divided by 3. So while there are an infinite number of pairs of numbers, there is a relationship between them. Whatever y is, x must be whatever y is, take away 5 all divided by 3. So we say that there's an infinite set of solutions.